So mining is the process of finding the hash with many combinations of block data. Block miners use special softwares and hardwares to solve complex mathematical problems, which involves making repeated attempts at generating a hash value that meets certain criteria. The first miner to successfully solve the problem and generate a hash that meets the criteria is rewarded with certain amount of cryptocurrency, as well as any transaction fees associated with the transactions added to the block. Once a block has been successfully mined, it is added to the blockchain and the network participants can verify the transactions contained in the block. The next block in the chain then begins to be mined, with miners competing to solve the next mathematical problem and earn the block reward. Now, though this cryptocurrency is created out of thin air, it takes great computational resources to find a block, as it is very difficult to mine a block and find suitable hash. It could go up to days to find a hash. There can be about there is about 1 in 200 trillion chance of finding a block, a hash. And the difficulty is adjusted every 2 weeks to maintain the approximate mining time of 10 minutes. The mining is also already very difficult, and there is this race to find the block first and add it to the network. If the node is successful in finding the block and broadcasting it to some other nodes, these nodes will update the ledger and not accept any new blocks from any runner-up miner. So the runner-up miner has to start all over again from scratch to find the next node, as the previous hash of the latest block will be updated. To understand how our code will mine a block, let me explain to you with this block with some random data I have added. So for this block, this hash has been generated by hashing all this data above. So we have the index of the block depending on the position of the block in the blockchain. We have previous hash, which is basically just the hash of the previous block. We have timestamp, which is a variable. We also need to add the list of transactions, which is constantly updating data. And lastly, we will be introducing nonce in hash. It is basically a random number which we can use to generate different combinations constantly. I'll talk more about this in a bit. And hash is what we get by hashing all the above data. So for this block, this hash has been generated by hashing all this above data. So we have the index of the block depending on the position of the block in the blockchain. Now this hash will be a hexadecimal base string. So instead of the binary form with just zeros and ones, we will be finding the hexadecimal string of the data, which ranges from 0 to F. It starts with 0 through 9 and then A, B, C, D, E, F. Our hash function will take all the data and give us a hash. As we saw on the website earlier, now the website took a fraction of second to generate the hash. So why is it so difficult to mine a block? So let's say For example, on hashing this data, we get this hash. This is a hexadecimal string, which is a hash for this block at this time. For this nonce right now, let's try creating next hash in some time difference. We are now hashing after 20 seconds. Although this time difference is huge in terms of mining blocks, we found the hash for this data as this, with a few zeros at the start. Now let's repeat it after a few seconds. And now we have found this hash, which is even lower. Now, don't see this as a pattern that as the time progresses, we will keep finding lower hashes. It is totally random because of the avalanche effect we talked earlier. The hash of the block changes completely as the time progresses. So, the requirement of the mining is to find the hash with very low value. Here, this has high values, so it will not qualify. This has more chance to be qualified, and this one has the highest chance of getting qualified. Now, the requirement value changes dynamically every 2 weeks. So, the blockchain network is so intelligent, it checks how many blocks are getting mined this week, and it adjusts the criteria to maintain the mining time to approximately 10 minutes. The rules differ in different cryptocurrencies, of course. Let us visualize it in this map. So the block will use combination of data and find hashes. Now a computer makes millions of calculations every second. So if we keep the timestamp constant and all other data the same, we will be finding hash of the same data millions of times, which will be a waste of energy. So we have added this nonce number here. We can update it in every attempt of finding a hash with low value, and we will be making a better use of our time. So let's suppose a case in which we use nonce as 1 and find hash of same size. Let's map it in the scale here. Okay, it's 5. Then we update nonce to 6 and find the hash again, and we find it here. So you might think, oh, the hash is decreasing with increasing nonce. It is inversely proportional. So let's just use a high nonce and see, we might find it here. And let's use another random number and check this. This is called the proof of work. The miner is working through many combinations to find the hash, and there we found an acceptable hash. Congratulations. So the point I'm trying to make here is the hash generation is totally random. We can only find an acceptable hash by trial and error. It is difficult to find a low hash, and it becomes even more challenging to compete with all the other nodes in the network and find the hash first. So it is really time consuming and energy consuming to mine a block. This is all about mining. Now, there is something called Byzantine fault tolerance. So let's suppose there is a king and three troops planning to attack a neighboring kingdom. And the protocol here is that king will communicate whether to attack the kingdom or retreat on his conscience, and the other comrades will communicate the message too, just to be more sure. Now if the king plans to attack, it will pass on the information to everyone. I have shown it here in blue arrow if a message is to attack and if the message is to retreat. I have shown it in red. So, in this way, every comrade will get confirmation to take action. Now, suppose one of the comrade is a traitor, and the comrade might pass on the wrong information. So, let's say if King announced the attack, so Comrade D here will then ask other members, but it receives message from Comrade B to retrieve from the fight. So he decides to count the vote as he received two votes and it was confusing for him to take the action. So he counted the vote and it turned out two votes for initiating an attack and one vote to retrieve. So as he follows the majority and goes ahead, the protocol prevented the traitor from losing the war, or prevented the traitor from making the king lose the war. Taking consensus handles wrongful intervention by traitors. This is called Byzantine fault tolerance. Similarly, in blockchain, if any attacker tries to attack a blockchain to manipulate data, the nodes communicate to one another in a decentralized way and avoid any changes in any blockchain or any node data.